Today is September 14th, 2016, and we are now starting to do proofs using transversals. Now, in the past, in Algebra 1, you saw proofs basically as algebraic proofs. Algebraic proofs started with an algebra equation as your given. Then your next statement was you did something algebraically to it, and the reason was what you did. Such as here, we distributed the 3, so it's distributive property. Then we added the 5, so it's combined like terms. After we added the 5, we combined like terms. We added the 2 and the 3. Then we added the 5 over, which is addition. Once we did that, we added the 30 to the other side, which is again addition, to get to 10x equals 50. Then we divided by 10, which division got us to x equals 5. This is a basic algebraic proof, but we're going to start geometric proofs, which are a little more entailed, and they involve a few more properties than the algebraic proofs did. Some examples. Here's a good example of a geometric proof that you will be doing in the next few days. If they give you A is parallel to B in this diagram right here, you mark with the arrows that A is parallel to B. They want you to use the corresponding angle theorem, which we abbreviate CA, to prove that angle 1 is congruent to angle 3. Now, using the corresponding angle theorem, we have to think, what do I have, because my final result is 1 is congruent to 3, but I have to use corresponding angle theorem to get there. So I need to look at my diagram and think, what do I have that is corresponding? That would be angles 2 and 3, right? So I know somewhere in there I have to state that angle 2 is congruent to angle 3. But I need to get angle 1 in there somehow, so I have to look and see, does angle 1 have any relationship to 2 or 3 in this diagram? It does have 1 to 3, but that would not help in justifying this. It does have a relationship to 2, though, doesn't it? They're vertical angles. So my first thing I'm going to state is angle 1 is congruent to angle 2 via vertical angles. Then I'm going to state what we said before, that angle 2 is congruent to angle 3, reason being corresponding angles. The last thing I need to see is if angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3, then I can simply say that angle 1 is congruent to angle 3 via the transitive property, which states the transitive property is a property that you use if you have this is equal to that, and that is equal to 4, then I can say this is equal to 4. That's the transitive property. It has to be in 3 steps. Something equals this equals that, so something equals that. Okay? Let's look at another example of a geometric proof. Again, you're given A is parallel to B, so we mark it on our diagram, as I have already done. Now they tell us without using CIA, which is consecutive interior angles. Consecutive interior angles. So I cannot just look up here and go, okay, 1 and 3 are consecutive interior angles, so that's how I know that their angles are the same. You can't do that. It's what it's telling you. It's telling you it wants to prove measure 1 plus measure of angle 3 equals 180 without using consecutive interior. So I have to look and I have to see, do I have anything else that could add to 180 that deals with any of those two angles, 1 or 3? And what I see is 1 and 2 are a linear pair. So I know that the measure of angle 1 plus the measure of angle 2 is equal to 180 by definition of a linear pair. Because they're a linear pair, I can say that those two angles add up to 180 degrees. I can also state that I know that angle 2 and angle 3 are congruent based on the alternate interior angles. Because they are alternate interior, they are congruent, so I can state that angle 2 is congruent to angle 3 based on alternate interior angles. Now, this is just angles, not measures of angles. So I have to convert this to, because I know these two angles are congruent, I know the measures of these two angles are congruent by the definition of congruence, which the definition of congruence simply states if two angles are congruent, then the measures of those angles are also congruent. Okay? Now, knowing that 1 plus 2 is 180, and knowing that the measure of 2 is the same as the measure of 3, I can state that the measure of angle 1 plus the measure of angle 3 is equal to 180 degrees by just simply substituting in the measure of angle 3 for the measure of angle 2 in my previous statement. And I have proven the measure of angle 1 plus the measure of angle 3 is 180 degrees. Now, I know that this seems a little overwhelming at this point, not to mention I've been showing you the proofs pre-filled in. So, let's try one that's not filled in, such as this one. The only thing I need to put and add is do not use AEA, which is alternate exterior angles, to prove this. So I set up my two-column proof. The first thing I'm told is M is parallel to N, so I mark that on my diagram, and that is given. Once I know this, I know I need to prove 1 is congruent to 3 without using alternate exterior angles. I need to look, is 1 congruent to anything else? And I see that 1 and angle 2 are corresponding angles, so I can state that angle 1 is congruent to angle 2, my reason being corresponding angles. Then I can also say what? Let's look. Angle 1 and angle 2 are corresponding. I'm trying to get to 3. Well, if I look at 2 and 3, do I know these are congruent? Yes, we do. Angle 2 is congruent to angle 3, and my reasoning behind that is they are vertical angles. Okay? So now I know that angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3. So, knowing these two statements, I can say that angle 1 is congruent to angle 3, and that would be using the transitive property. Okay, so that one was a little easier. Let's try another one. Here we go. They want us to prove, given measure of that line M is parallel to line N, they want us to prove that angle 4 is congruent to angle 2 without using AIA, alternate interior angles, without using that. Okay, so let's start my proof. You always start your proof with what you're given. So M is parallel to N. That is always the start, is your given. Okay? So I need to prove 4 is congruent to 2. How I do that is I need to draw in, and I need to look, do I have any congruencies other than that does not deal with alternate interior? Let's look. Do I see any other angle types here? I could say that angle 4 is congruent to angle 1, right? Okay, so I know that angle 4 is congruent to angle 1, being as they are vertical angles. And that would be my reasoning, vertical angle. So I've linked 4 to 1, but I need to link it to 2 somehow. So I look, is there any way to link 4 to 2 without alternate interior at this moment in time in my proof? No, there's not. But is there any way to link 2 into my last statement, 4 and 1? Well, I see that 1 and 2 are corresponding angles, and I know that corresponding angles are congruent, so I can simply say that angle 1 is congruent to angle 2, my reasoning being corresponding angles. Now, I have that angle 4 is congruent to angle 1, and angle 1 is congruent to angle 2. So knowing those two things, I can say angle 4 is congruent to angle 2. Again, this was a 3-step process. 4 is 1, 1 is 2, so 4 is 2. So this again is the transitive property. Okay? One last one, and it's going to get more challenging. Here we go. I'm immediately going to draw my 2-column proof. I have 2 things given here, so I need to list them. And because they do not deal with the same thing, I need to list them separately. So my first given is that M is parallel to N. So mark my little arrows to show that these 2 lines are parallel. Okay. Then I was also given that angle 2 is congruent to angle 5. Oops. Let me fix this real quick. That's also another given, right? Alright, so I need to get that 2 and 5 are congruent. That's what they've told me. So I could mark it on here. Okay? But what they want me to get to is that V is parallel to W. If I'm looking on here, the only 2 angles that could prove that V and W were parallel would have to be an angle type. And the only angle I have on W is angle 5. Do I have an angle type on the same transversal, which would be N, that can go with angle 5? Angle 3, right? And I know that these 2 are not congruent because they're consecutive interior, they're supplementary. So I know I'm dealing with the measure of angle 5 plus the measure of angle 3 being equal to 180. In order to get there, I need to talk about the measure of the angles. So the first thing I need to do is I need to convert that angle 2 being congruent to angle 5 is the same as the measure of angle 2 being congruent to the measure of angle 5 by reason of the definition of congruence. Because I've got to get down to an angle plus an angle is 180, I need to be talking about the measures of the angles and not just the angles. So I must add in this step. Now, My next step is, I've got to get somehow to where the measure of angle 3 plus the measure of angle 5 is 180. The only way to get there is I've got angle 2 is congruent to 5, right? So I need to think, is there another angle I could use that could get me to where I could plug in or substitute in the 5 for the 2. Now I know 2 and 1 are a linear pair, but is that going to help me get to 5? It could. You could go that route. It's going to be more steps because you'd have to prove that 2 and 1 add to 180. Then you have to prove that 1 is the same as 3. That's the long way about it. You can say that 2 plus 3 is 180 based on consecutive interior, right? So that's the route we're going to go. The measure of angle 2 plus the measure of angle 3 equals 180. And we know that because they are consecutive interior angles, or CIA for your abbreviation. Now, knowing what I know about the measure of angle 2 and the measure of angle 5, I can come in and substitute in the measure of angle 5 for the measure of angle 2 in that statement. And that is simple substitution. I'm just substituting it in. Now, because I know that the measure of angle 5 plus the measure of angle 3 is 180, if these two add up to 180, I have now proven that V is parallel to W using consecutive interior angles postulate. Because that's what 5 plus 3 is 180 is the consecutive interior angle postulate. Okay, so this is your brief introduction to proofs. I hope this helps, but don't worry, there is more on the way.